2n, it means n more is there plus 1 more is there. So but obvious this expression is smaller than this expression. So we can write you can write this. In place of this we have written this. Now what is this? So the length of u v square w lies between two consecutive perfect squares. It is n square and the consecutive number of n is n plus 1. So the length of u v square w lies between two perfect squares, consecutive perfect squares. It means the length of this string is not a perfect square. There is no perfect square lies between these two consecutive perfect squares. So if we say that we have 9 and we have 16, the length lies between this. So is there any perfect square between these two perfect squares? No. So it means its length is not a perfect square. If it is not a perfect square, it means it is not satisfies this condition. So this u v square w will not become a part of capital L. So hence a contradiction. So we are able to find the value of I so that we got the contradiction. So is it clear at this point? So here what we'll write is, that is the length of u v square w lies properly between n square and n plus 1 square and is not a perfect square. Thus u v square w is not in capital L a contradiction. We conclude that capital L is not correct. Any doubt in it? Okay. So now we are so lot more examples are there that is not feasible to cover here. So you can go through, any doubt is there and let me know. So we have covered pumping lemma for regular sets. Definition is clear to all. And what are the applications? So this comes under the applications of pumping lemma. So then we are moving to the context-free grammar and languages. The second portion of language section C. So write down what we mean by context-free grammar. A context-free grammar a context free grammar, or in short we write CFG. Context free grammar is a finite set of variables, also called non-terminals, or syntactic categories, each of which represents a language. Each of which represents a language. Each of which represents a language. The languages represented by the variables, are described recursively in terms of each other, and primitive symbols called terminals. The rules relating the variables are called productions. A typical production states that the language associated with the given variable contains strings that are formed by concatenating strings from the languages of certain other variables possibly along with some terminals. So now in context-free grammar, suppose we need to represent the English language or any natural language. So what is the structure of English language? Sentence, we'll say what is the sentence structure of English language? What comes first? We have three parts in the sentence. So what are the portions? Subject, verb, object. Right. So how to frame a sentence? So in abstraction we say that we have a noun phrase and then we have a verb phrase. right? So this is the abstract view of the sentence. So the English sentence can be formed by two parts. One is the noun phrase and another is the verb phrase. So now how the noun phrase is composed of? So we say that we have adjective and then another noun phrase may be there along with that adjective. So this is the recursive definition of production using the variables. Noun phrase is again used over here. So recursively we are using the definition of variable in the production, framing of production. So that noun phrase can only consist of noun also. Only noun can be there in the noun phrase. There is no hard and fast rule that adjective must be there or another noun phrase can be there. So only noun can also be composed of noun phrase. So then, what we mean by noun? So we say that we have kept noun as a void. Then what is this adjective? We say that little. Right. So now if you need to compose some sentence from here, will you be able to compose it? So now first we see the terminologies. So this, the name written in the angle brackets, so they are the variables, right? So this is a variable, that's why we have given a rule for expanding it. Then again this is a variable that is expanded to this, and this can be expanded to this also. So there are two production rules that can be used for expanding this noun phrase. Then noun can be replaced with void. Now this cannot be expanded further. And then this is a terminal. Right? So we can take it like a, in graphs, what we have? Variables and terminals. So terminals at the bottom and variables in between. So these are the variables that can be expanded further, and for the variables we are giving the definitions. And what are the stopping points? They are the terminals. So these are the terminals, and adjective is a, we can replace at the end with little. So when we are composing the sentence, so at the end we have all the terminals, but we have started with the first production rule, then we go on applying the productions on it, and at the last we are replacing all the variables with the terminals, and we are finally getting a sentence out of it. So what we are doing is we are extracting, we are composing the strings from the context free grammar. So write down the formal definition of context free grammar. So we write, as in finite automata, we explain the finite automata in 5 tuple definition. So here we have 4 tuple definition. So it is, we are using the symbol capital G for the context free grammar. As for the finite automata, we were using the symbol capital M. So here for the context free grammar, normally we use the symbol capital G. And this is defined as capital V, capital T, P and capital S. So what is capital V? Capital V is the set of variables. Capital T is set of terminals. And capital P, set of production rules. Not productions, but set of production rules. So if we are putting this into curly braces, so this is capital P. All the production rules are put into a set. So this is production. And what is capital S?
Start symbol.
Start symbol. So what is the start symbol over here in this productions? Sentence. So this becomes the capital S here. The language generated by capital G. The language generated by capital G, and that we denote as L of G. Similarly, what we have done is the language generated language for finite automata, it was represented by L of M. And similarly for context free grammar we are writing as L of G. So the language generated by capital G is set of all the strings or words with the property that W is in T star. What is T star? T. So W is composed of only terminals. And we started deriving from capital S. S is the start symbol. We starting derivation from capital S. We are applying multiple production rules. How to represent multiple production rules? So if I am writing only capital G over here, it means one production rule has been applied. If I am applying star over here also, so multiple productions are applied. And finally, we are able to derive W. Right? So now all the strings that are derivable from capital S, they are the language of context free. So full stop, that is, write down, that is, a string is in LG, a string is in language of grammar LG if, first point, the string consists solely of terminals. The string consists solely of terminals. So it is clear from this fact. So W is in T star. So this means the string solely consists of terminals. Second point, the string can be derived from capital S. The string can be derived from capital S. So both the points are clear. So next, in the next line, right, we call capital L a context-free language. We call capital L a context-free language if it is LG, if it is LG for some context-free grammar. Next definition is also very important. Write down a string of terminals, and variables, alpha is called a sentential form, if S derives alpha. So now what we mean by sentential form? First, in this definition, what we have talked about is W, and W solely consists of terminals. So that is not a sentential form. Sentential form means the alpha is composed mix of terminals and variables. Right? The intermediate form we can say. So that is a sentential form. That is composed of both variables and terminals. So that is a sentential form. So now we will do one example. Write down the context-free grammar write down the context-free grammar for all the strings consisting of an equal number of A's and B's. An equal number of A's and B's.